So first thing to remember, these are your actual numbers. This you multiply by 0.4 to get your milligrams per liter as calcium carbonate, right? That's the first thing. So both of these columns have to be corrected for the dilution that we use, 25 to 75. Multiply that for your statistics, and multiply that when you're trying to figure out alkalinity, hardness, softening, all that calculation that we're doing. Okay, so now that you have these numbers, what are we trying to do? All right, determine the alkalinity. Well, that's pretty much, this is your alkalinity right here, right? That's pretty straightforward. Statistics, you know how to do that. Okay, the alum. So the hypothetical here is that you added 25 milligrams per liter of alum to coagulate this water, okay? So based on what Dr. Thomas talked about and what I mentioned to you, the ratio of the equivalent weights is 1 to 2. So what you would do is you'd multiply the 25 milligrams per liter times 1 over 2, you'd get 12.5, okay? So that's 12.5 milligrams per liter as calcium carbonate. Because the 1 over 2 cancels out your alum, then you have calcium carbonate left, right? So you're converting from alum to calcium carbonate. So what this question is asking is how much is consumed? Well, 12.5 milligrams per liter of calcium carbonate is consumed if you add 25 milligrams per liter of alum, okay? So that's your one number that you want to get, 12.5. So then you compare that number to whatever number you got here. Well, obviously, this is your initial alkalinity number. It's much higher than your consumed alkalinity number, right? So what is the question asking? Is the amount of alkalinity consumed less than, equal to, or greater than? Well, consumed is 12.5, so it's a lot less than your initial. Okay, so that's the answer to that one. So that's 50% right there. Pretty straightforward, right? Okay, hardness is a little bit trickier. Okay, well, calcium total hardness, again, your columns here, 0.4 is your multiplier, correction factor for dilution. Make sure you use units as calcium carbonate. That's important. Milligrams per liter as calcium carbonate. Okay? Statistics on both of those columns. Statistics after you corrected. How would you do this? Calculate the concentration of calcium and magnesium, knowing what you have here.
Subtract.
Yeah, I mean, once you get your 0.4 multiplier on here, say it's, let's make it easy. If you had 500, you multiply it by 0.4, you have 200. So that means you have 200 milligrams per liter calcium hardness, all right? If you multiply that times your equivalent weights, which I can't erase any of that. And what you want to do, stick it right here. So you have 200 milligrams per liter, all right, calcium carbonate, based on your actual numbers. Okay, you multiply that times your equivalent weight, what's the equivalent weight of calcium?
Okay. Oh, no.
So molecular weight is what, 40, right? So equivalent weight is 20. Okay, and then your calcium carbonate, we all know, is 50. All right, so boom, boom. This is 400 by 50.
200.
Is what?
Oh.
Oh, it's 4,000, right? 2 over 5, 400 divided by 5. It's 80. Okay. So that's your milligrams per liter calcium carbonate. So that's your concentration of calcium carbonate. Based on the actual numbers you got, multiplied by the ratio of the equivalent weights, this is what it's asking for. The same thing for magnesium. Okay? So that's this here. Then you compare this magnesium to the 40 milligrams per liter calcium carbonate that we talked about. And it should be less than 40 to meet EPA requirements. All right. Okay. Is that clear? Is that all right? Okay. Out of here so it doesn't confuse the issue. So get your concentrations of that, and then the last part is the softening. Okay, now the example 11.7 is pretty good in the book that Dr. Thomas talked about. That'll walk you through it. We're going to use selective calcium removal. I would suggest you set up a bar graph, because you know what your concentrations of calcium and magnesium are based on the numbers you actually got using your titration method. So you have the cation bar, the alkalinity. You can set that alkalinity, which is the lower part of the bar, based on the numbers that you got using your alkalinity titration experiment. Okay, so you can set that up as in the book, and then you can figure out how much lime and soda ash you need to remove all that. Okay, and Dr. Thomas went through it for 20-30 minutes, so I'm not going to rehash it. But the bottom line is, you're going to need some lime to remove your calcium, because there is a lot of calcium in the water. There isn't a lot of magnesium in the water, and you'll figure out that is based on the difference of those two numbers that you got. You got the calcium, the total, the difference is the magnesium. Okay, so that's where your starting point is for your magnesium. So once you have all that, you may, this is just a hint, you may not need soda ash, because you may not have any non-carbonate hardness to remove. Hint, hint. But you'll need lime. You'll need the calcium hydroxide, because there's definitely calcium. But you may not need soda ash, which is the sodium carbonate, because there may not be any non-carbonate hardness. But that's something for you to think about as you go through here. Okay? And that's it. That's what that last question is asking you.